Hey everybody, this is Larry. This is day 8 of the Leetcode Day Challenge. Hit the like button. Ooh, unbox surprise. Yay, 10 coins. Happy lead coding. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Longest increasing subsequence. So very much have been said about this one. This is almost like a standard problem and is 2,500, which in Leetcode is probably too slow and you want to do an n log n anyway. Yeah. So this one this one is kind of tricky to explain, or at least no, explain it. The explanation is okay, but it is tricky to come up with. To be honest, if you haven't seen it before, I think this is now one of those things that you just have to have someone explain it to you and then just know. I don't know that there's a thing that like you haven't seen it before, even if you know binary search and stuff like this. It may be way hard to get to. I mean, maybe you'll get in a couple of days or something like this. But I think just in general, yeah. And also doesn't help that now it is a medium. I think the n square solution is pretty okay. And n square solution is the longest path in the DAG, and I think that's something that you should learn as well. And I wish that because this becomes trivia and stuff, just coming out with dynamic programming in the sense that you just have to kind of figure it out and then just remember it to a degree. The idea here is that you keep an array of in a way there's parts greedy and a monotonically increasing sequence, which is how, or monotonically decrease increasing sequence, which is how you get the answer here, right? And then here the idea is that, so now let's say you have a longest array and it's going to have zero. The longest array with zero elements is going to have a negative infinity, right? Yeah, maybe I think that's true. I don't remember anymore, to be honest. But here the idea is this: for every number we go, okay, can we construct a longest increasing subsequence of length 0? Can we construct a longest subsequence of length 1 and 2 and so forth, right? So if you write it naively, you might write something like, okay, if let's just say for t and I don't know, something big, right? Let's just say dot dot dot. I mean, this isn't real code, so maybe just say infinity, and then you go, okay, so the longest, if the longest of t, and this is longest of t is equal to the longest increasing subsequence that ends with this number, right? Yeah. So then now we go, okay, if this is longer than that, what happens? Well, if this is longer than that, then we can obviously create a number, but then now we're going to see if we can create the next number, right? Meaning that, okay, now we know that there is going to be a longest subsequence, increasing subsequence. Oh, I missed a word, of length t that ends with this number. Because, okay, so you can kind of think about the binary search property as that, at a certain point, it goes, is there a longest increasing subsequence of length t that ends with this new number? And then it becomes yes, 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 to no, 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 right? Because after no, it becomes no. So then now you have to find the latest number where that is, and then add 1 to that, and then, add 1 to that number. Basically, for example, if the longest, let's just say t is 0 for now, right? If longest of t of 0, if the current number is strictly increasing, it is strictly increasing. If the number is greater than that, then we can update longest of t plus 1, right? Something like that. Except for in this case, so part of this case is that there's binary. There's a binary search, but it's also part of this case is that I said binary, but I meant greedy. And what do I mean by greedy? What I mean by greedy is that, okay, let's say the two sequences of longest of t, right? then you want it to be the smallest number because, well, if it's a bigger number, then you know it doesn't help your future improvement, right? So it's going to look something like this, where basically you want to get the minimum number between this and x, and then you just do this for all of infinity. Yeah, assuming that obviously if long as t is not infinity or something like this, right? Or if it's used. Right now we only have one element, so it's a little bit weird. You can imagine also having this, but with all the elements or something. But in any case, and then the idea here is that, well, if you really pay attention to this, and I'm not going to really show it in detail because it's very long, but if you really pay attention here, then you realize that in a way, it is going to be, even though the answer is true, it's going to be, the number is going to be smaller, meaning that this is going to be the small number all the way up to the last number that you update, right? Because you always want to, because if you return one number, then by definition, because if you look at how this goes, right, maybe another way of saying this is, okay, if longest of t plus 1 is greater than x, then we update, right? Right, now that we kind of write it that way. And then now maybe I'll just move it up a little bit and something like this, right? Well, it turns out that in this case, there's only one number that where this is going to be the case, right? Meaning that, all right, we'll even switch the signs a little bit. We'll have it right here like this. And then you can see that we're just trying to find a number where this is the case. If it is the case, to update. If this is not the case, then we don't have to update. And of course, and that's basically the idea. And the idea here then is noticing that from here, because there's only one number, you can do a binary search on this number. And that's really all the ideas. That's all the explanation. I know that maybe I could do some drawing, but I'm feeling a little unwell today, to be honest. I think I ate, or I drank too much bubble tea, which is actually maybe a little bit embarrassing to admit. But yeah. Also, yeah, I was gonna say something about me being in Istanbul in a couple of weeks. So yeah, if you're in Turkey and would like to let me know your favorite Turkey tips or whatever, or if you want to grab a drink or whatever. Maybe not a drink, I don't know if that's a thing, but anyway, yeah, so here then now the way that you can do it then is just by binary search. So we want to get the, what are we doing, left or right? So we want to get a number where this is true, right? And because this is going to be increasing, we want to put the number in which yeah, we can insert x, because it's strictly increasing. Maybe something like this. Let me think about this for a second. Because basically we're binary searching for the number in which, so okay, I'm just trying to think about the tie breaking rules, which is why it's a little bit weird. Okay, so well, this is the index that we will update. So okay, so if it's the same, then we will update the same, because that means that strictly decreasing is the one before. So we have indexes equal to this, and then now if index is greater than longest, then longest append x. Otherwise, longest of index is equal to x, because by definition this is going to be smaller or equal to, or I mean that the number that returns is going to be either equal to or bigger. So then this is basically the min function that we talked about, and then at the very end we can return the length of the longest, maybe -1. But yeah, but this is also a ridiculous algorithm that to come up with in general. Yeah, I thought it was going to be -1. Because the last index is because it goes 0, 1, 2, 3, and then you want 3 and now whatever. All right, cool. Let's give it a submit. Apparently I've done this before about a year ago. So yeah, that's pretty much it. That's the idea. Let me know what you think. We have an 860-day streak, which is, I guess, a sort of an even number. That's kind of nice. Yeah, so this one I would also say it took me a long time to get, even knowing the existence of this. So maybe this is a little bit of a, this is there at the end, and okay, fine. This is n O of n time, or n space, O of n log n time. So that's just the complex analysis. And a little bit of a backstory for this is that I know that it is hard. They put it a medium maybe for the n square and not n log n. And for me, it took about years to learn this by my own. Because for a long time this was considered hard, and that they just didn't ask it on the problems. But I would also say that back then, back then there weren't as many binary search libraries, so you would have to write it manually, which isn't that bad. But people just didn't have all this code to read and optimize together, right? So this was considered a little bit hard. But nowadays, I guess people consider it standard, even though I don't know that I agree with it per se, because I think it's just something that versus something that you can come up with. But yeah. Anyway, I'm going to do an extra bonus question. So did I accept? Oh, yeah. So definitely check that out. Did I click on? That's all I have for today. So stay good, stay healthy, to good mental health. I'll see you later and take care. Bye-bye.